Number 29. The graph in figure 140 shows the velocity versus time for a bullet as it is fired from a gun, travels a short distance, and enters a block of wood. Compute the acceleration at the times marked A, B, and C. We collect our information. For part A, we need to read from the graph that the time t1 is 0 seconds, and then t2 is equal to 0.001 seconds. Also from the graph, we see that v1 is 0 meters per second, and v2 is 500 meters per second. To calculate the acceleration, we go back to the definition. Acceleration is equal to the change in velocity divided by the change in time. This is the same as v2 minus v1 over t2 minus t1. Plugging in our numbers, we have 500 meters per second minus 0 meters per second divided by 0.001 seconds minus 0 seconds. Running all of that through the calculator, we get a final answer of 5 times 10 to the 5th meters per second squared. Part A. Part B. We're going to take our 2's and they now become our 1's. So what was t2 here now becomes t1, and what was v2 now becomes v1. We look to the graph for our next set of statistics. t2 is 0.0024 seconds. And from the graph, we read v2 to be 500 meters per second. So acceleration is equal to v2 minus v1 over t2 minus t1. Now we have 500 meters per second minus 500 meters per second, all divided by 0.0024 seconds minus 0.001 seconds. The top of the fraction is 0. Therefore, acceleration is 0. Remember that a flat line on a graph is going to be 0 meters per second squared for acceleration. And lastly, part C. Our t2 and v2 now become our t1, 0.0024 seconds, and v1 of 500 meters per second. We go back to the graph for our secondary conditions. We have t2, that's equal to 0.0026 seconds. And our final velocity is back to 0. Acceleration is equal to v2 minus v1 over t2 minus t1. We have 0 meters per second minus 500 meters per second divided by 0.0026 seconds minus 0.0024 seconds. Just trying to keep things neat. So we have a negative 500 divided by a 0.0002 seconds, and that gives us a final answer of negative 2.5 times 10 to the 6th meters per second squared.